Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.4, Problem 8. This is Section 2.4, Problem number 8. It says multiply the matrices, and now what you have is one matrix times some parentheses, and within the parentheses are two matrices that have to be added together. So you have to do the work in parentheses first, and then you can do the work outside of the parentheses. So initially I'm going to just ignore anything that's outside of the parentheses and focus only on the work inside the parentheses. So in the parentheses you have two matrices to add. The first one is 4, 3 in the top row, 1, 2 in the second row. And the second matrix is 7, 0 in the top row, negative 1, 5 in the second row. So first let's add those together. And again, you're going to add the values in the corresponding positions. So I'm going to add upper left plus upper left. So 4 plus 7 will make an 11 in the upper left of my answer. Upper right plus upper right will be 3 plus 0. So that's 3 for the upper right of the answer. And then bottom left and bottom left, positive 1 plus negative 1 is 0. And then bottom right plus bottom right, 2 plus 5 is 7. So that's the work in the parentheses. And you need to multiply that times the matrix that is in front of the parentheses, or to the left of the parentheses. So what the problem amounts to now is the matrix 2, negative 2 in the top row, 1, negative 1 in the bottom row, that's what was outside the parentheses, times the work we got as the result we got as from the parentheses, the matrix 11, 3 in the top row, 0, 7 in the bottom row. Now in order to multiply two matrices, you need to check to see if there is a solution. Again, you're checking to see if the number of columns in the first matrix is equal to the number of rows in the second matrix. Easiest way to do that, write the dimensions underneath each matrix and see if the inner numbers match. So the first matrix is a 2 by 2 matrix because it has 2 rows and 2 columns. Again, say the number of rows first and the number of columns. The second matrix is also a 2 by 2 matrix because it has 2 rows and 2 columns. And when you write those dimensions underneath the matrix and you check to see if the inner numbers match, they do. Both inner numbers are 2. So because the inner numbers match when you've written the dimensions, there is a solution, and the size of the solution is given by the outer values when you've written the dimensions underneath the matrix. So the multiplication has a solution, and the solution is going to have the dimensions 2 by 2. It'll have 2 rows and 2 columns. So when I do this work out, it will have 2 rows and 2 columns. And again, I'll write those big boxes, and I'll do the work inside the boxes, and then when I'm done, I'll just write only the answer. So I'm going to set up a matrix for my answer with 2 rows and 2 columns with these big boxes that I'll fill in. So to start this off, I'm going to multiply the top row of the first matrix, 2, negative 2, times the first column of the second matrix, 11, 0. And when I do that, first times first, 2 times 11 is what I'll put in my box, plus second times second, which will be negative 2 times 0. So first times first, 2 times 11 is 22. Second times second, negative 2 times 0 is 0. And 22 plus 0 is 22. And now, why did the answer go in the spot that it did? I multiply the top row of the first matrix times the first column of the second matrix, and the answer I got went in the top row and first column of the solution. So now I go over one box. I'm going to multiply the top row of the first matrix, 2, negative 2, times the first column of the second matrix, 3, 7. So I'm going to first do first times first, which is 2 times 3, plus second times second, which is negative 2 times 7. So first times first, 2 times 3 is 6. Second times second, negative 2 times 7 is negative 14. So 6 plus a negative 14, or just simply 6 minus 14, is negative 8. And again, I got that answer by multiplying the top row of the first matrix times the second column of the second matrix, and I put the result I got in the top row and second column of the solution. So now I'm going to fill in the bottom boxes. I'm going to start by multiplying the bottom row of the first matrix, 1, negative 1, times the first column of the second matrix, 11, 0. So first times first will be 1 times 11, plus second times second is negative 1 times 0. So first times first, 1 times 11 is 11. And then plus second times second, negative 1 times 0 is 0. 11 plus 0 is 11. And again, notice I multiplied the bottom row of the first matrix times the first column of the second matrix, and I put my answer in the bottom row and first column of the solution. So finally, the last box to fill in, I'm going to multiply the bottom row of the first matrix, 1, negative 1, times the second column of the second matrix, 3, 7. So when I multiply first times first, I'm going to multiply 1 times 3. And second times second, I'm going to multiply negative 1 times 7. So first times first, 1 times 3 is 3. And then negative 1 times 7 for the second times second is negative 7. Positive 3 plus a negative 7 is really 3 minus 7, which is negative 4. And as I usually point out, I multiply the bottom row of the first matrix times the second column of the second matrix. So I put the result that I got from that work in the bottom row and second column of the solution. So now that is the solution, but you usually don't write it with all the work. So right next to the original problem, I'll write the final answer. I'm going to have a matrix with 22, negative 8 in the top row, and I'll have one row underneath that with 11 and negative 4 as the second row. And that is the final solution for this problem.